So we're going to go over some of the math behind the next part, which is pretty much the biggest part of the program. So once you finish this, you'll be pretty much done, is basically how we actually move the cards. So at this point, you've already coded, the cards flipping over and starting at the bottom of the screen, and you have a background. Now you just need to move the cards around and then pick which one you think is the ace. But the trick there is telling the computer how to move the cards, because the computer needs to know how many possible ways they can move them that make sense. Luckily for us, we don't have that many cards, so there aren't that many combinations, and I can show you exactly how many there are. So we could ask this question: how many ways can we sort these three cards? So we have two cards and an ace. Only three possible positions. So we could sort it like this, where we switch the first two cards, switch 5 and the ace, and it looks like this: ace and then the 5. Another option would be switching the first and the last card, so it goes from a 5-10 to a 5 and a 10. And the last option is you could switch the last two cards, so ace flips from here to here, 10 flips from here to here. These are the only three ways that we could seemingly change how these cards are ordered. And it turns out there's actually an equation for figuring this out, for how many possible combinations there are in our system. You probably haven't seen an equation quite like this before, and this exclamation mark might look kind of weird if you've never seen it, but this is actually a cool mathematical function called a factorial. So I'm going to explain this to you, then show you how we could use this equation to figure out how many combinations there are without having to count them one by one like we just did. Because counting them one by one is really annoying if you have a whole lot of combinations. So first off, let's talk about this factorial thing, this exclamation part, what that means. So factorials, they're pretty cool. And it's actually kind of simple. Basically, if you have a factorial, it'll be a number followed by an exclamation mark, and all you have to do is multiply one by one that number minus 1 and keep going down. So for instance, 2 factorial is just 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2, and it just goes like that forever. So if you had 100 factorial, it would be 100 times 99 times 98 times 97, all the way down to 1. So as you can see, the numbers get pretty big pretty quickly. But that's all it means when you have a factorial with that exclamation mark. There's some kind of cool properties about that. For instance, since we know that 2 factorial is 2 times 1, 3 factorial could also be written as 3 times 2 factorial, because that would be, again, 3 times 2 times 1. And the same thing for 4 factorial could be written as 4 times 3 factorial. And 5 factorial could be written as 5 times 4 times 3 factorial, because they're all saying the same thing. It's just 3 times 2 times 1 for 3 factorial. 4 is factorial is 4 times 3 times 2 times 1. And 5 factorial is 5 times 4 times 3 times 2 times 1. These are just different ways of writing it, and it gets the same answer. So now we could talk about the original equation that we had here for figuring out the number of combinations. So we know what the factorial means, but we don't know what n or k is yet. But those are pretty easy. N is just the number of things that you have, and k is the number of them that you're choosing. So for our example that we talked about earlier, we have 3 things, 3 cards, and when we're moving them, we're only choosing 2 of them. So for our example, we have 3 cards, so n is equal to 3. And when we decide to move them, we're only choosing 2 of the cards. That makes k equal to 2. So we can plug them into this equation that we had, and if we plug them in with n being 3 and k being 2, you get 3 factorial over 3 minus 2 factorial times 2 factorial. We already talked about what these are equal to. We know 3 factorial is 3 times 2 times 1. 3 times 2 is 6. 6 times 1 is 6, so you get 6 on top. 3 minus 2 is 1, and 1 factorial is just 1, so that's where this 1 comes from. And likewise, we said 2 factorial is just 2 times 1, which is 2, so that's where this 2 comes from. 1 times 2 is 2 again, And so, boom, you should have three combinations, which is exactly what we talked about before, where the three combinations were this, this, and this. So that means for our program, we need to make sure that there's three different ways that we can move the cards. Either we move the first two, the first and the third, or the last two cards. And so we're going to next move into Tynker again to talk about how to do that.